Hey, have you guys heard of the expression or the term latitude before? And so latitude, back in geography, maybe you guys did that in sixth grade maybe. Did you guys do much of that in middle school? Okay, so when you're looking at latitude, what latitude is it involves kind of looking at a side view of the Earth. If you look at the side view of the Earth, what is this line called? The equator. And when you're looking at the equator, anything that lies above and below, it's a lot like the bearings that we dealt with. They're always going to be able to identify in terms of an acute angle measure. Right? And so when you look at the latitudes, latitudes are these parallel lines to the equator. Okay, we'll probably pretty much stay in the northern hemisphere when we're doing problems on this. But when you're looking for latitudes, so let's say you have a latitude of 30 degrees. What a latitude of 30 degrees means is if you take an imaginary angle with a vertex at the center of the Earth, and you form an angle from the equator to that location on the Earth's surface, the central angle measure that's formed is the latitude, 30 degrees. So when you're looking through or looking for these types of problems, what you might see is what is the distance from a city with a 30-degree latitude from the equator. Okay. This becomes a distance on a curve problem. And what is the relationship, or what is this called, the distance on this curve? It's called a arc length. So when you're looking at this, we're taking our arc length, which is given by the formula m over 360 times c, and then you're just going to solve this arc length. Now, the majority of the time, or you will be given some piece of information to determine which equation you want to use. It might just be this equation. I might tell you that the circumference of the Earth is estimated at one of the easy to work with estimates is 40,000 kilometers is the circumference of the Earth. So you might just say, if this is the case, take 30 over 360 times 40,000, and that's going to give you your solution in terms of kilometers. Okay. Latitudes are also referred to as parallels. Again, it's these parallel lines here. So this is also referred to as the 30th parallel. Okay. And if you've ever paid attention when you're driving down to Salem, you'll pass a sign along highway or along I-5 that says you are now at the 45th parallel. That means Salem, or right in that area, is located exactly midway between the equator and the North Pole. So that's what that means. It means that that angle that would be formed would be exactly 45 degrees. Okay, so if I gave you a problem that asked you, let's say you have a city on the 50th parallel, okay, which also is just another way of saying it has 50-degree latitude, and I asked you how far to the North Pole. Okay, so if you're dealing with this city on the 50th parallel, that means that this whole angle right here is 50 degrees. So when you want to find the distance to the North Pole, which is up here now, so it's a slightly different type of problem, when you see this reference, what is the central angle that's going to correspond to this arc? If 50 degrees gets you to the 50th parallel, what's left? 40. So this arc measure winds up being 40. So when you calculate this, your arc length is going to be 40 over 360 times whatever the estimate you're using. Whether it's circumference, diameter, or radius, it'll give you some estimate for that. Okay. All right, so what I want you guys to do here, just really quickly, is I want you to see if you can identify How far is JHS from the North Pole? Okay, so this involves you finding the latitude, finding the circumference of the Earth, and I want you to be to find it in miles, and I want you to find it to 2 decimal places. And then calculate based on that. So this is going to involve you finding it online. You can work with your groups if you want. Okay, just take a moment or two, see if you can find that information. Okay, so be as specific as possible. So you can use 5 decimal places on this. Okay, 45.48638. All right, so the circumference of the Earth is what? Did anybody get miles? Marcus? Good. Okay, that's the one that I found as well. So again, it's just an estimate. The Earth changes slightly, and it's not completely circular, but this is the estimate. So if we plug this information in, what is the m value that we're going to use? Is it 45.48638? No, make sure, remember, we're finding this distance, so we have to subtract the latitude from 90 to get the remaining central angle measure. Okay, so that winds up being 44.51362 over 360, and we're going to multiply that by 24,901.55. And so when we calculate this, we get what distance, approximately? $3,000. About right here. Okay, so this is the distance from this location to the North Pole.